This is day 3. Starting on page 4, we're doing example 5. We're going to learn how to create scatter plots and smooth line graphs in Excel. So the problem asks us to graph this function 16 minus 5x minus x squared, and it asks us to use a window from x is negative 30 up to x is positive 30. First thing I do is I create an input-output table from x equals negative 30 up to x equals positive 30. So my x value starts at negative 30, and the cell below that, I want it to equal 1 plus the cell above it. So it'll take negative 30 and add 1. And then I'm going to drag that formula down so that it continues to add 1 to the cell above it. All right. So I have the x values stretching from x is negative 30 up to x is positive 30. In column B, I've put the f of x function, so it equals 16 minus 5x minus x squared, where x is being referenced as the cell to the left. Drag that formula down. All right, to create a scatter plot, highlight the entire input-output table that you created as if you were going to copy and paste it. I highlight the whole thing, including the x and f of x titles. I then go to Insert. In the Insert tab, you'll see a Graphs and Charts area. See a little picture that looks like a scatter plot. So let's go ahead and first draw a scatter plot. It plots the points from your input-output table. There you are. You can go in and you can edit things like the title and so forth. You see that the chart tools are available up here. There's design things, format changes you can make. You can add axis labels and so forth, change your increments. You can play with all that if you're handing in a homework or a project. So that's a scatter plot. Just highlight it and click scatter plot. Pretty simple. Another common thing that we're going to do in this class is create smooth line graphs. It's just like a scatter plot. You highlight the entire input-output table, but instead of clicking on the scatter plot option, you're going to click on the smooth line, scatter with smooth lines option, like so. Then it looks more like a smooth graph of the function with no breaks and holes in between each plotted point. Now example 6 asks us to create a smooth line graph for the function p of t. It tells us that t represents the number of months that have passed since they created a new lake. P of t is the approximate number of fish in the lake. So again, I'm creating an input-output table first. We're inputting t months, outputting p of t fish in the lake, and we want to graph this in increments of 5-month increments all the way up to 200 months. So we'll start the input-output table at 0 months, which is when the lake was created, and I want it to increment by 5s. So I want the next cell to equal 5 plus the cell above it. I'm going to drag that down until it goes up to 200 months. All right, so I've dragged it down, so we're looking at month 0 through month 200. In column B, I've typed the formula for the function p of t. Careful here to make sure you have parentheses around the entire denominator and that you have parentheses around that exponent. It's e raised to the negative 0.09 times the x value. Again, if you put your cursor in the bottom right-hand corner and double-click, it drags that formula all the way down through month 200. All right, and it asks us then to create a nice smooth line graph. So I highlight it as if I'm going to copy and paste it. I go to the Insert tab and select the smooth line graph, and there it is. So it inputs number of months that have passed and outputs the number of fish in the lake approximately. There it is, nice graph there. Now, if you like to, if you're creating a paper in Word, you can actually copy and paste this whole graph and type it right into and paste it right into a Word function like so. Just copies and pastes right in there. All right, it then asks us in part B, when will there be 300,000 fish in the pond? Use Excel to solve. So we want to find when the function has an output value of 300,000. All right, so I'm going to go back here to my Excel file. We're trying to find when The output value is 300,000. You see that it's approximately here. Here is when there's 300,418-ish fish at about 130 months. To have Excel solve for when it's equal to exactly 300,000, we're going to use the solver feature. So I put my cursor in the cell that has the Y value in it, the output value. We go to the Data tab and click Solver. I want cell B28 that has the formula in it to equal a value of 300,000 by changing cell A28, the X value cell. Click Solve, and it edits it and says at 129.947 months, it's approximately 300,000. So you see that's 299,999.9. So after about 130 months, 129.9 months, identify the right tail behavior and then explain what it means in real terms. Okay, so here's the graph. Right tail behavior of the function. What's happening over here on the right tail as the input value increases up to infinity, the height of this function, it looks like it's approaching a height of about 450,000. It's getting closer and closer and closer to that height. That means as the time goes on, as the months go by, the P of T, the number of fish, is getting closer and closer to 450,000. That's actually called the carrying capacity of this lake. Where is the function increasing and concave down? So I see that this function from 0 months up to forever after is always increasing. But I see that it's increasing concave up, and then it changes to increasing concave down. Seems that there's an inflection point somewhere around about maybe 125. X is 125, T is 125. So after 125 months, it looks like this function is increasing concave down. In interval notation, we would say that it's from a low of, we'll say, 125. And the high then, since it goes on forever after, is infinity from month 125 and after. This function is increasing concave down. In inequality notation, we would say 125 is less than t is less than infinity, or just t is greater than 125. And in real world terms, we're saying after month 125, the number of fish in the lake begins to increase at a decreasing rate. It's increasing very fast at month 125, and then it's increasing at a slower and slower and slower rate after that. In fact, over here we see it's almost flat. There's hardly any increase at all in the number of fish each year, each month.